recording.
Okay. Just to be
Absolutely.
sure.
I've hosted so many Zoom
Yeah, but they
calls.
know I'm here.
So anyway, so I'm Bill, and let me turn it over
It
to.
was, and then off.
We'll go around with intros. Who you are and where you're from.
Sorry?
Robert, if you go next.
All right, Robert
Oh,
from the
this is a
Netherlands.
repeat from last week, but the guy forgot to record it.
Hold on.
I'm hearing
It's a shame.
your recording back. That true?
Go ahead, Robert.
Okay. All right. Robert from Amsterdam. Been following Deming since 2005, roughly, and I'm getting into him deeper and deeper, especially because of his views on the system and the influence the system has on people and his humanistic approach.
Okay, Diane.
Diane Kulisek. I actually sat in on the first round of this, but glad to be back. And as you saw, Yoshio and I were going back and forth a little bit in email. But I'm looking forward to refreshing my mind about what was covered and participating again today. Big Deming advocate, quality and regulatory affairs pro, doing mostly consulting now.
And a former coworker at Rocketdyne.
Yes.
All right, William, go ahead.
Hi, I'm Will Dugan. I'm new here. I'm from New York. I've been sort of coached by Bill here for a few weeks now about Deming methods, about sort of how applicable they are to all kinds of different institutions, and sort of looking more specifically at things like rocketry, which sort of is my focus, more of an engineering background. But I think it has a lot of different applications to a lot of systems. So I think it's pretty interesting to sort of learn about.
And unlike the rest of us, William's being exposed to this before starting in industry as a recent college graduate. Right, Tom, go ahead.
You're on mute, Tom.
No, Tom.
Oh,
Okay, Tom.
There you go.
hi, can you hear me?
Yes.
Yes.
Hi. So yeah, well, I'm from the UK. I work for a government agency in their quality department. And kind of discovered Deming in the last couple of years, and I was interested in hearing the talk.
All right, Tom, welcome. And then Jim.
I think he is slightly distracted right now.
He's both muted and turned his video off. So
Yeah, he's at his daughter's swim meet. All right. So you should be able to share it. Go ahead and try.
Okay. Oops. Let's see. Let me see what's going on here. Sorry. Okay, here we go. So I will quickly introduce myself. My name is Yoshio Muki. I've been involved, or at least I would call myself a avid student of Deming and a reasonably sometimes successful practitioner of Deming philosophy. How's that? And I'm a retired engineering director from aerospace. Near the end of my career, I discovered Deming probably with about maybe 10 years or so left in my 10, 15 years left to go in my career. And after having learned about Deming, it changed my attitudes towards leadership as well as innovation and technology, and also how organizations function and actually behave. Thinking of organization not only as a collection of human beings, but a collection of processes and organizations and how they interact. The Deming lens puts a really good context, puts those things in really good context for understanding the behaviors and the idiosyncrasies. So I will get started. And so today we're going to talk about learners and knowers. Last week when I did this, I think it was Mardi Gras, was a Tuesday. It was also a Lunar New Year. And I think it was the beginning of Ramadan. There was a lot of changeovers going on last Tuesday. Today's just another Tuesday, so I apologize for being such a mundane day. So an overview of what I'm going to talk about. First, I want to talk about why this presentation exists. Spend a little time talking about learning. And then that's part one of the discussion. Part two of the discussion is knowing. So you got learners and you got knowers. And I want to be able to compare the two of them. That's the two-part session that we're going to do today. So what's the motivation? Well, the motivation for this is this came about as a result of a conversation I had with friends many years ago. And the question started with, what are the key elements of innovation? And what I did, when I started thinking about that, I said, well, there's a lot of tools associated with innovation. You can talk about QFD in the Six Sigma DFSS world, or you can talk about TRIZ in patent world. And then I start thinking about personality traits such as curiosity and creativity. And so I came up with a presentation to talk about that. And the resulting presentation was pretty dry. And what I came to realize that innovation wasn't really about tools and personalities. It seemed to have a lot more to do with the culture that the individuals live within. And aligning that observation with the teachings of Dr. Deming and Russ Akoff and Gypsy Rani, as well as contemporaries like Adam Grant or Richard Fagelin and others, resulted in a presentation that I called Safe to Fail. And what I'm going to be presenting to you in the first half of this presentation is kind of a shortened version of that Safe to Fail presentation. And at last year's forum in Santa Clarita, we talked a lot about safety and trust in an organization, and innovation as a cultural thing and safety and trust as a cultural thing kind of work together. And so I thought it was a good time to dust off this presentation, repackage it a little bit, and present it to, and Bill asked me to present this at the forum this year, which I'm really excited about. But to put those two things together into one presentation, and you are going to be subject to that now. So first thing, let's talk about learning, and not just about learning in school, but lifelong learning for an individual, as well as I want to expand that to lifelong learning from an organizational context. So the question that I have to pose to the audience is, are you comfortable with failure? Yes or no? You don't have to answer that now, but I want to give you a few examples of failures in sports, pop culture, technology, business. And the question is, did these failures result in later success or decline of the organization? And more importantly, were these failures deliberate? So as an example, I'm going to quote Michael Jordan. He says, "I've missed more than 9,000 shots in my career. I've lost almost 300 games. 26 times I've been trusted to take the game-winning shot and missed. I failed over and over again in my life, and that is why I succeed." This is a little bit of a dated example because Michael Jordan's been retired for quite a while, but it really gets to the point of a person who's comfortable with failure. And the other thing also is this: Michael Jordan is an example of being a part of a successful system. Michael Jordan, in and of himself, he's a great basketball player, but he couldn't have reached the heights that he reached if he wasn't part of the system that he was in, meaning the Bulls organization. His teammates Scottie Pippen and Dennis Rodman, as well as the coach that he had, the coach Phil Jackson, who was who studied Zen philosophy as well as other Eastern thoughts, and you can think of him as how he manages the teams that he's coached. Is he managed them as if he was a true systems thinker in the line of Dr. Deming and Russ Akoff. So, and a more current example is this one here. This one was earlier this month. I'm sorry, not earlier this month. This was April of last year. And this is a soundbite from the Rethinking podcast with Adam Grant. This is an interview with Megan Rapinoe and Sue Bird. Now, this is Sue Bird talking about trying something new. So I'm going to let you listen through that. And there's a little bit of cussing in here, so please bear with me.
I do find that what I'm doing a lot in my retirement with some of like the new things, new ventures, new businesses, whatever it is I am reverting back to sports a lot. Let's say one of us was trying to add a new move, right? You know you're going to be terrible at the start. You know you're going to be embarrassed. Likely you're going to face embarrassment because you're so bad at it. And you also know that you got to keep showing up, and every day there's a marginal gain, and you're totally bought into that, so much so that you don't even really notice the embarrassment, and you're totally okay with the fact that you're fucking up left and right. And it's just a part of it. And ultimately what happens, you get it, you get the move down, and you're great at it. And sometimes in these new things, I'm finding I want to be great right away, and I have to like remind myself of, no, that's not how this works. And that I feel like is a skill that I'm so thankful that I learned in sports that I'm taking with me now for sure.
Yeah, I haven't been bad at something that I'm spending a lot of time and effort on in a really long time, maybe ever. And I'm like, oh, this is terrible. How does anyone even fight through this? I don't want to be doing this. But so we're doing it.
All right, so now moving on to other examples in more in the industry world. 3M Post-it notes is an example of possibly a deliberate failure. Procter & Gamble does something interesting. They put out less than ideal products into the marketplace just to see, because first of all, they recognize that the market is fickle and always shifting. And so they want to throw stuff out there and then look for the feedback to find out which way the market is moving, what the consumer preference is. So that, again, is kind of a form of a deliberate failure. Oh, and by the way, deliberate failure, I think Harvard Business School refers to that as intelligent failure. And another example is pilots who deliberately put themselves in failure conditions in flight simulators. And why do they do that? Because when that happens to them in real life, they have to be able to respond right now. So again, putting yourself in a bad situation, even though you may know what you're doing in real life, you say, I would never let that happen. Even with those intentions, those things can happen. And when they do, you better be prepared to respond. So flight simulators are very valuable for training yourself to respond in adverse situations. So they put themselves into the bad conditions deliberately so they know how to respond in real life. Another example, and this was great, this was earlier this month, February 2nd. This was John Oliver on the Late Show with Stephen Colbert, and he's talking about how stand-up comics are thinking in terms of constantly failing in order to improve their craft.
Now, you also do a residency at the Beacon Theater here in New York. I do. Up on the Upper West Side. You and Seth together? Always with Seth. You and Seth. Yeah, you've said the stand-up stage is your favorite place in the world, and I'm just curious, what do you get from that? Because I admire stand-ups. I was an improv guy. I would never did a stand-up. What is it you get about that you don't get from your weekly show?
Well, I guess with the weekly show, with these shows, right, be they daily or weekly, once you're kind of making a disposable product for yourself. Where you make it, it's done, and then you move on to the next
You'll never
thing.
do those jokes again.
Exactly. Where with stand-up, you can work on it more and more and tinker with things at a much longer time frame. So I love it for that. Yeah. And I love it for the emotional calluses it gives you when failure can no longer hurt you. I've been hurt so many times by stand-up audiences. There is no... See, even that, I felt nothing.
How long did it take you? How long did it take you to get that callus? Because my first night on Second City professionally, our director said to us afterwards, you have to learn to love the bomb.
Yeah.
And meaning not like get through it and you'll get it better tomorrow. You actually have to love that feeling, like inhaling it, like you're huffing failure, like it's a high.
Because it's a nightmare. Like it's literally lots of people's nightmare is having a cold sweat thinking about doing stand-up and not going well. But if you have that happen 100 times, nothing after that feels like anything. You're just functionally dead inside in a very useful way.
So... Okay, hope you understand the moral of that story. If you spend any time with Bill, I'm sure he's talked about the rooster Chanticleer, so I'm going to read it to you. It's a parable. The barnyard rooster Chanticleer had a theory. He crowed every morning, putting forth all his energy, flapping his wings. The sun came up. The connection was clear. His crowing caused the sun to come up. There was no question about his importance. Then there came a snag. He forgot one morning to crow. The sun came up anyhow. Crestfallen, he saw his theory in need of revision. Without his theory, he would never had nothing to revise, nothing to learn. And this is from Dr. Deming's book, The New Economics, 1994. So let's expand on the definition of theory. So theory is a statement which conveys a prediction of the future with a chance of being wrong. And the emphasis is on chance of being wrong. We don't know what's going to happen for sure. We know what we think should happen, but there's no guarantee that that's what's going to be the outcome. But it's important enough, and we do want to find out. So that's the statement of the theory. And then now the process is to go find out and see if you can validate the theory or not. So let's talk about product development as a system. So this is, Dr. Deming put this out, I think originally on a chalkboard in Japan in front of, I think it was Toyota executives, I'm not sure. Anyways, this is how he sees how product development works as a system, starting with consumer research, design and redesign, and then it goes into testing, and if everything works out good, it goes out to the customer. So, but around this, in the book Out of the Crisis, he presents this diagram again, and then in the paragraph surrounding that diagram in Out of the Crisis, he says, management learned about their responsibilities for improvement at every stage. So what does he mean by management learned about their responsibilities to improve at every stage? What I think he meant was actually applying the PDSA cycle. And the obvious place that, if you look at that chart, the obvious place to apply the PDSA cycle is right there at the design and redesign. In an aerospace company, which is my background, that would be the engineering department. You design something, check it out. Does it fit? Does it all fit together? Does it meet the customer needs? Fine. And if it doesn't, just keep designing and redesign. But from an organizational perspective, that PDSA actually applies everywhere. So planning, go out there and see what the consumer wants. Come up with a plan. So your theory is, I think the consumer needs this. Because that's what I hear from the consumer. Then put a plan together to come up with a product, service, or product process or service to address that need. Then it goes to the design or engineering department to do the planning. And there's some prototyping that takes place. Then you test it out, make sure it meets customer needs, make sure that the thing that's being designed or the service that's being designed is within the capabilities of that company or that organization, and make sure that it makes financial sense for the company. It can be made profitably and sustainably. So and then if all those wickets are met, then you act. So that's a PDSA cycle from a large organizational level. And when you do the act phase, you put it into production. And once you do that, everything works out good. Then the consumer will get the final product. Now, I think what Deming meant to say was also that within each of these organizations, each of these departments, they give the local leadership and the local members there the ability to do their own PDSA cycles to improve internally within their department, their processes, and how they function. But then also the other part of management, larger organizational level, is that they have to make sure that all these interfaces also have their own little PDSA cycles. So in between each department, these little PDSA cycles can take place so that the handoffs are smoother, that the receiving department gets what they want, and those things are communicated back to the providing organizations so that the handoff, like I said, the handoffs are smooth and efficient without any go backs and things like that. So if an organization does all these things well, that is, they respond to the customer needs, each organization is responsible for improving their internal processes, and then the whole company or the organization as a whole is responsible for managing the interfaces so that there's good communication of information good handoff of materials between each of the different departments. Well, what's the result of that? Well, then the result is obviously happy consumers. So let's take a look at, so this is kind of a Deming organization on steroids where there's constant learning going on. So if you look at this picture, what do I see? Well, I see a roaring river, lots of eddy currents just all over the place. And all these little eddy currents are representative of like a PDSA cycle. So lots of positive churn going on everywhere, constantly improving to make sure that the customer is happy. Okay, so let's talk about just the opposite, a non-learning organization. Oh, I'm sorry. So going back, PDSA, every time you go through that PDSA cycle, the whole idea is as you're doing that, you're learning something new. So learning and improving, learning and improving. So now what happens in a non-learning organization? Well, not much consumer research is done because if you're knowing organization, non-learning, that means you already know. You already know what the customer wants. You don't even have to go out there and ask. So I'm smart enough to know what the customer wants. Next, you're smart enough to know that the first time you make a design, it's pretty damn good, so I really don't have to do much redesign. I already know how this thing's going to behave, so why do I need to test anything? So by the time this goes out to the customer, that's really the first time when you realize that something's not quite right, when the customer gets his hands on a product or service and says, this is not what I really want. So that's kind of I gave you a kind of a Deming on steroids type organization, and on the polar opposite, I give you this organization here. So in this case, pity the customer. So I talked a little bit about the PDSA cycle. So I want to kind of dissect the PDSA cycle. Obviously, we talk about the PDSA cycle, and every time we talk about it, we always assume that the plan is good, the doing is good, the study is good, and everything checks out properly, or the study shows that we validated the theory. So now we're going to go act on that, put it into production, or pot it down into the organizational processes, or whatever you do. But that's not always the case. And then from this point on, I'm going to start playing around with the A. And I'm going to ask you to, maybe this is a little bit of Deming heresy, but I'm going to ask you to bear with me here. Okay? So now I'm going to take the A, and then I'm going to substitute it with another word. So did the study show that the plan fell short, but still had some merits? So let's revise our assumptions, find out where we fell short, revise our plan, and start over. So that's the adjust cycle. So if the benefits outweigh the risks that were identified, well, let's spend a little bit of time just to minimize those risks, and then readjust the plan and start over again. So you can have a final product with more benefits and less downsides. Or maybe the plan had maybe the study showed that the plan had some other positive impact in an adjacent area. Well, adjust the target department or target product. So the PDSA, adjusting something, whether the plan or the actual target, might be a viable interpretation of the A. So another A is if the theory and the plan was proven correct, where there were other learnings during the study phase that could be adapted for subsequent PDSA cycles in an adjacent area or another product. Now, Velcro was originally intended for textile and fashion industry, but in that area it didn't really break through. Later, excuse me. Later during the Apollo missions, though, NASA adopted Velcro as a way to keep things in place inside a space capsule, because obviously magnets wouldn't be a very good idea because of all the sensitive electronics on board. Velcro was a perfect solution to keep things in place in a zero-G environment. Obviously, I think you've probably heard about the stories of when they initially started using Velcro, they found out it was very flammable. Once they got that squared away, there was a lot of extensive use of Velcro in the space program, And then once that caught on, it became very popular, and it became a very commodity item for consumers for many household applications. So you had a good plan, you just didn't have the right target in mind. So that's what I call the adapt. Instead of PDS act, it's just adapt to a different application. And then the final A, and this is where I really get into the heresy, Deming heresy, I think, is the abandon off-ramp and what comes next. So in the PDSA cycle, what if the study phase showed that the plan had no success, no chance of success in hindsight, and no place for application in any other context? Should this be cause for punishment? And the reason I kind of came to this was I was talking to a general manager at a company I worked for, and we were talking about the PDSA cycle, and I said, the A doesn't always have to stand for act. A could stand for, abandon or abort. And he looks at me and says, look, if you have to abandon a plan, that means your plan wasn't good enough. And I shouldn't trust you with doing, if you're that much of a screw up, I don't think I should ever trust you with another project ever again. And I said, wow, that's kind of punitive, So instead of looking at it as a opportunity for management to punish you, what if I just choose that as a learning opportunity? So what can I learn from this cycle if I have to abandon something? So I'll go back to, I'll quote Russ Akoff, and he says, we can only learn from our mistakes by identifying them, determining their source, and correcting them. People learn from their own mistakes, more from their own mistakes than from the successes of others. And this is from Akoff and Greenberg, Turning Learning Right Side Up, Putting Education Back on Track, 2008. So abandon the plan, but don't abandon the learning opportunity. Now here's how I envision an organization that general manager would have had. So if you have to abandon the PDSA cycle, first thing is punishment. I'm not going to give you any more projects. And then fear of further retribution. And the only way for me to stay viable in that company is to revert to what worked, or do the same thing over and over again, not take any more chances, not go beyond outside what I know works. What that does is lead to stagnation. And if it was obvious to the rest of the people in that company, that would lead to decline of the organization. Now I'm going to flip that over into more of a Deming type organization, or from a red pen to a blue pen, to use a Bill terminology. So obviously there's a little bit of introspection. Wow, what assumptions did I blow? What did I do wrong? There's a little bit of discomfort because it means that you have to accept the fact that you aren't as perfect or as smart as you thought you were. There's also the discomfort of knowing that you have to, however much effort you put into that project before you have to abandon it, all that chunk of work has to be cast aside. Nobody wants to throw away something that you've invested into, but you may have to. And then you have, now that you got that baggage out of your mind, now it's time to study, figure out how you made those bad assumptions, and then start a new learning and start a PDSA cycle again. And within a supportive organization, you will be allowed to provide more. You'll be allowed to lead other PDSA cycles or new development cycles. So, organization as a whole will grow in those kinds of environments. So the question is, in the environment or the company that you work for or you're part of, are you above the line or below the line here? So a learning organization, in my mind, has to have a culture of trust and free of fear. This is some of the things we talked about last year at the forum. And if I've convinced you that that innovation arises from a culture of trust and free of fear, what does leadership in a trusting organization look like? So this list is adopted from a book Trustology by Richard Fagelin in 2013. I think he's got a couple of editions since then. But here's a list of what I consider to be very important elements of trust as a leader if you want to create an environment not only of trust, but a trusting organization that can foster innovation. Okay? And I'll get back to this later, so you don't have to read it all here. So I'm going to give some closing thoughts on learning. This is a quote. This is my quote. I will let you fail, but I'll never let you be a failure. And I'm sure other people have used that too. This came about at a time when one of my direct reports was working on a project, and he was afraid that he may not get to a successful conclusion. And he was very concerned about the repercussions if he didn't get to a good conclusion of what he was doing. And then there's a little bit of a complaint in there that he felt that I was more or less standing by watching him fail when he thought that I had the answer to help, to pull him out of whatever fear situation that he was in. But I wanted to let him go ahead and test out his own theory. But I told him, look, you do that, but after you're done, if you're successful, great. If your theory didn't work out, okay, fine. So you failed on being able to prove your theory, but let's spend some time studying that. Let's find out what went wrong, and then we'll start all over again. But by no means will I punish you for not getting it right the first time. And so what that did was he felt comfortable moving forward, even though there was always a little thing in the back of his head saying, I could fail. But he also knew that even if he did, he would be given a second chance, and that he would not be, I would not going to call him out on the carpet or whatever metaphor that you use for punishment. And after he got through that, we did the after action discussion about what went wrong, what we could do better, and he went back and got it right the next time. Great. And since then, and other folks in my organization, they saw that and they were able to move ahead with greater confidence and try different things. So instead of doing the same thing over and over again, each one was pushing their own boundaries as time went on because of this, because they knew that this was my philosophy when it comes to leading people. Okay. So the final thought is, do you ever delight in watching a child learning or watching babies learning to walk? What do you notice? They fall a lot. You never question why they fall. It's obvious that they are learning, but why do they get back up? When they pull themselves up to try again, why are they smiling and giggling instead of crying? The answer is that they find joy in learning, growing, and gaining mastery. And this is from Susan Fowler, from Why Motivating People Doesn't Work and What Does, 2017. So if you acknowledge that enjoying learning is a human trait and a desire, can we take this concept of learning through failure to our professional lives as knowledge workers? As leaders and team members, can we create a safe and trusting environment for this to take place? So that's where I'll leave the learning part of it. And now we're going to move into knowing organization. And here, so we're done talking about learning. Prior to this, I think I used the term non-learning, but I'm just going to go ahead and start using the term knowing. So we're going to do a case study. And the case study is the Titan Submersible Disaster. So I think everybody knows about this, and some of this might be redundant or just a rehash of what you already know, but bear with me. So in 2018, or June 18th of 2023, the Titan Submersible imploded during a dive to the RMS Titanic at the depth of 12,500 feet, killing all five on board. Later that year, in October, the United States Coast Guard convened a Marine Board of Investigation, or MBI, on the Titan Submersible Disaster. The intent of the MBI was to understand what happened with the development of the Titan Submersible and to come up with new regulatory recommendations to the governing agencies and voluntary committees to prevent such a thing from ever happening again. In 2024, September 2024, the Coast Guard convened a hearing interviewing, industry experts and OceanGate. OceanGate is the name of the company, current and former employees, mission specialists, and various other folks involved in the submersible industry. Also folks from, I think there was people from Boeing as well, people who are experts in composites. In August 2025, the final report of the MBI was released, and basically the punchline is key findings and contributing factors in the causality, and includes 17 safety recommendations aimed at strengthening oversight of submersible operations, improving coordination among federal agencies, and closing gaps in international maritime policy. So that's kind of the technical recommendations. And then, of course, I hope most of you have already seen some of I suppose most of you have seen the documentaries on Netflix and HBO, and there's a lot of other people offering up their opinions and their observations on YouTube and other social media. Now, as part of the Marine Board investigation, Kemper Engineering Services was tasked with reviewing available engineering data to identify gaps in the design and development phase of the Titan submersible. I was a consultant to KES, and I was tasked with reviewing the documentation from traditional systems engineering, stress analysis, testing, and risk management perspectives. And then I submitted that, and that was incorporated into the KES final report, which was presented to the Coast Guard MBI as item number CG108. Now, after I submitted my findings to Kemper, I kind of sat back and said, well, that was interesting. I mean, there's a lot of things that went on. But then I said, well, what would my findings look like if I looked at everything that I reviewed, but I looked at it not from an engineering, or like I said, the systems engineering, stress analysis, that perspective, but what if I looked at it from through a Deming lens? What would my conclusions look like? So I'm going to present a little bit of that to you in this section here. Okay, I'm going to give you a little background on OceanGate, the company that developed the Titan submersible. They were formed in 2009 by Stockton Rush and Guillermo Solnline. Solnline had long left the company before the Titan disaster. Now, OceanGate publicized itself as an innovative company, and you've seen that in CBS News Sunday Morning with David Pogue, and all over other traditional media, Bloomberg Business News, Sky News, GeekWire. You see a lot of interviews there, as well as things on, like I said, YouTube. In 2021, OceanGate began taking paying passengers down to the Titanic. Now, from the period of 2016 to 2023, there were 3 different directors of engineering. And from my perspective, from my professional background, if I see 3 directors of engineering in that period of time, I would say that's pretty fast turnover. But then, so that was kind of a red flag to me when I was looking at that. But then I looked at other startup companies, and high turnover for startup companies is not that unusual. The interesting part is that there was no director of engineering at the time of the Titan disaster. Okay. Moving on. So innovation at OceanGate. They had 1 patent, and the patent was granted in 2021. The title of the patent is Systems and Methods for Curing, Testing, Validating, Rating, and Monitoring the Integrity of Composite Structures. So the novelty of this patent is the use of acoustic emissions detectors to listen for cracks and dislocations of fibers in the composite hull. Later on, this will be referred to as real-time monitoring. The intent here is that as the composite hull goes down to depth, certain amount of damage will take place in the composite material, delamination between the layers, dislocation of the fibers from the matrix material, things like that. The premise was that if you start to hear those, you can characterize those acoustic emissions or acoustic indications, acoustic signals, and from that you can say, oh, I have a little bit of damage, but I still have plenty of time between now and catastrophic failure. So all I have to do is keep track of the amount of damage that the hull accrues, and then at a certain time when I feel that that's got enough and I'm at risk, I'll take the hull offline and build a new hull. So that's kind of the intent of that patent. I'm going to talk about the Titan dive history. From here's the distribution for the full range of distributions. The x-axis represents the maximum depth the dives achieved, and then the vertical axis, number of times that the Titan dove to that depth. Now, the good news is, out of 87 total dives, there were 13 successful dives down to the Titanic. But then the other part that's not so good is more than half the dives were less than 10 meters, which is pretty trivial. So let's go a little bit deeper. Now let's look at the time history of the different dives. Here's just across the bottom is the dive dates from starting in I think it's from 2017 out to 2023. You'll see a lot of shallow dives, a couple of deep dives in this time frame here. And then there's a period of storage, and then a couple of deep dives, period of storage, and then a couple of deep dives here. This dive 80 on July 15th of 2022, I believe, became the focus of the NTSB, National Transportation Safety Board investigation. The NTSB was subcontracted under the U.S. Coast Guard to support the investigation. They did a lot of good work here, and when they went through all the data from the Titan submersible, this dive 80 became a focus of their investigation. So let's take a close look at dive 80. So what happens, it took place in July 15th, 2022. It went down to the Titanic, and approaching the surface, the crew as well as the surface team heard a loud bang coming from the hull. And the sound was recorded on the acoustic emission of the real-time monitoring system. Now, since this occurred near the surface and not at depth, it was written off as a crash between the Titan and the support vessel, and not a pressure effect or anything that could damage the hull. So what you see on the chart on the right is the green line, I hope it looks like green on your side, is the depth. The x-axis is the time duration of the dive. The purple lines, the purple hash on the bottom, across the bottom, those are the signals coming out of the acoustic emissions sensors. I think it was, I can't remember which channel it was, but it doesn't matter. Anyways, you can see that it dives to the Titanic depth. It dwells around the Titanic depth, and as it starts to come up to the surface, here it is approaching the surface, and all of a sudden you hear this big bang. And it went beyond full scale, but nobody bothered to give it a second look. So this chart was developed by the NTSB. There's no indication that OceanGate looked at this data in this way or any other way. They just said, well, something happened, but it must have just banged into something, no big deal, and merely go forth. So the NTSB did a further review on the same data, and they looked at a strain gauge nearby. I apologize for people who don't have a technical background, but so I'm going to get a little bit granular here. But NTSB looked at this data. The blue and black curves represent the ocean depth versus the strain gauge output of dive 75 and 80, the two deep dives to the Titanic. And you can see that the blue and black lines, they go straight up and then they come straight back down, basically in a pretty straight line. Now in the subsequent dives, 81, 82, and 83, the green, red, and purple lines, something different starts to happen. And before you take off, it starts the departure point of the strain gauge is actually offset from the prior dives, and then when it comes back up, it comes like this again. It departs from the prior strain gauge behavior. And so, zooming in a little bit closer, that offset became a focus of the NTSB investigation. And again, after reviewing all the reams of data that was provided by OceanGate, there was nothing really to indicate that anything was ever done in terms of dissecting that data to this detail. All right, now I'm going to go to just a table of the dive histories from dive 80 to 87. So dive 80 is the one where that noise was discovered. 81, 82, 83. Successful dives to the Titanic and PH Mystery. Pretty significant depth, all three of those. And then there was 300 days of transportation and storage. And then a couple of shallow dives en route to the Titanic and at Grand Banks. And then dive 88 is the one that is the disaster. But what I want to draw your attention to here is the 300 days of transportation and storage. What did that look like for the Titanic? I mean, I'm sorry, not the Titanic, but the Titan Submersible. This is kind of what it looked like. The Titan was stored in a storage yard in St. John's Bay in New Brunswick, Canada, in very harsh Canadian winter, completely uncovered, just sitting there in a parking lot like that, not covered, not any kind of protection other than that blue cap over the viewport on the front. I found another great picture that was shared on Instagram or something. I tried to reach out to the person who posted it to see if I can use it in this presentation. I didn't get anything back, so unfortunately I'm not able to. I don't feel comfortable sharing that here, but it just shows that some of the covers on the back of the hull of the Titan hull was removed, and a lot of the electronics and the equipment were exposed to the environment. And so there was snow, and then and on top of that there was trash and stuff littered around on the ground around the Titan submersible whilst in storage. So in dive 88, this was on June 18th. This had Stockton Rush, Paul-Henri Najolet, Hamish Harding, Shadadat Dawood's son Suleiman on board and starting their dive to the Titanic. Now what I'm going to play for you is what the investigators believe that this sound of the Titan hull collapsing. This was recorded on a National Oceanic and Atmospheric Administration passive acoustic recorder approximately 900 miles away from the Titan submersible. But it is suspected to be the sound of the hull collapsing. Oops. So that's kind of what it sounded like from afar, from 900 miles away. Let's see what it looks like up close. So these pictures were taken by the recovery unmanned recovery vehicle, and you can see obviously something horrible happened here. And I think if anybody's curious, the U.S. Coast Guard, one of their conclusions was that the death of the 5 people on board was instantaneous, that the collapse was catastrophic and immediate. So I say that so if any of you are worried if people suffered during this event, I believe that they did not. And that's the U.S. Coast Guard's position as well. Looking at it on a micro scale, this is kind of what it looks like. So you can see that the composite, the composites has delaminated on here. In other areas, there are indications that the adhesive was fractured, and there's other places where it's apparent that there were voids in the adhesive layer, as indicated here in these cross sections. And this is from an area of the hull that wasn't damaged, not like this, but under the microscope it looks like that. And these are places that would be looking down the fabric, and this is looking down onto the fabric. So what you see here would be equivalent to what you would see here. Now, anybody who knows anything about composites manufacturing, if you look at this picture on the lower left, that's the biggest red flag of all. What Titan did, what OceanGate did, or the subcontractors did, was they needed a composite hull that was 5 inches thick, and they didn't feel comfortable being able to cure a 5-inch thick piece of composite to say. So they said, we know we're comfortable with curing 1 inch thick composite. So they wrapped a 1 inch thick composite wrap around the mandrel or the form, and they cured it, which is basically heating it in an oven, and then they bring it out, and then the intent was to wrap another inch over it, stick it back into the oven and cure it some more, bring it back out, wrap it, repeat 5 times. Now, once what they found out was when they pulled it out of the oven or the furnace, it's more of an oven, not that hot, they found that the outer diameter had waves in it, and they didn't like that. So they decided, well, let's just go ahead and grind out the rough spot or the bumps. You're smiling, Robert. Look like you know what's going on. Anyways, anybody who knows anything about composites knows that the strength of the composites is in the fibers. And if you disrupt the fibers like they're doing here, the actual strength of the composite pretty much goes away. You've lost it. But they seem to do that without any second thoughts, and that was a process no. And there's also no science or no current art on what it means to do multiple cures on one piece of composite wrap. They did this 5 times, so the inner layer got cured 5 times. Usually the standard practice is just to cure it once. Nobody knows exactly what happens to composites when they get cured that many times. So now that was the technology, and now this is where I put on my Deming lens. I want to start talking about the culture. So during the investigation, there was a lot uncovered about the technical gaps in the development of the Titan submersible. But from a culture perspective, there's a lot of things that happened that really put up red flags. What they did a lot of is they ignored or belittled other industry best practices, other industry experts. They even ignored some of their analysis results, as well as ignored their test results. And interestingly enough, they ignored their warning devices, which is that real-time monitoring system that I had mentioned earlier. The other interesting thing was, did anybody raise a hand? Okay. Another thing they did was they skirted government regulations. Titan was not flagged by any country nor classed by any organization. What does that mean? It means that the Titan submersible was no different than like you and I building a soapbox derby car in our garage. There's no rules that dictate how we do this. I can go ahead and do whatever I want, put it out on the road, or go take it out to a parking lot and fiddle around with it all I want. Nobody can stop me from doing that. So the Titan submersible was basically something that OceanGate could build, and if they get out to international waters, they can do whatever they wanted. Passengers were not referred to as passengers, but as mission specialists. And that distinction is very, very important because that changes the legal and liability relationship between the passengers and OceanGate. By being called mission specialists, they became essentially employees as opposed to paying passengers. Therefore, they own part of the risk, and they become part of the organization, not a paying passenger. So, all right. And there's a big long section on that in the Coast Guard report as well. So the MBI report in the very first page or the very first paragraph of the executive summary, which is the very first thing, the first half of that paragraph talks about some of the technical and the administrative or the regulatory stuff. But the second paragraph says this. Let's see. The investigation further identified the need for proper corporate governance, a professional workplace culture, and improved regulatory oversight, in particular for novel vessel designs and operations. So what jumped out to me out of that paragraph was the phrase, a professional workplace culture. So let's dig a little bit deeper and see what the Coast Guard means when they say there's a need for professional workplace culture. Or better yet, let's look at what it looks like or what it sounds like when that is absent. So I'm going to give you a peek behind the curtain, and I'm going to invite you to a little. Hey, Mike. I didn't see you. So I'm going to give you a little peek behind the curtain at a red pen company. This is what I'm giving you is a recording or snippets from a recording from a meeting that took place at OceanGate. And I don't know where these red lines are coming from. This meeting was presented to the Coast Guard as part of the investigation. The meeting took place at the OceanGate facility in Everett, Washington on January 19th, 2018. The meeting lasted a little bit over 2 hours. I'm not going to play the whole thing for you. The attendees were David Lockridge, at the time was Director of Marine Operations, Stockton Rush, the CEO, Scott Griffiths, the Director of Logistics and Quality Assurance, Tony Nissen, who was the Director of Engineering at the time, and Bonnie Carl, who was the HR and Finance Director, and at the time she was also training to become a pilot for the Titan submersible. So the meeting was initiated by David Lockridge, who had serious safety concerns about the Titan submersible, and he felt that they weren't being adequately addressed by engineering or by Stockton Rush or anybody else in the organization. So this meeting was being recorded. I think he was the one that was responsible for the recording. What I'm going to show you is some sound bites, and what you're going to hear is a lot of things that are clear examples of non-Deming or antithesis of system of profound knowledge behavior that's demonstrated. And to refresher, the system of profound knowledge, appreciation for a system, there was none. Understanding variations, there was none. No theory of knowledge, no learning was obviously being shown here. No psychology, the interaction between the people, the hubris, arrogance, and tunnel vision being demonstrated by Stockton Rush and some of the others is really shocking. And the sound bites are grouped together more or less by type of dysfunction and not necessarily presented in chronological order. Again, I didn't go through the sound bites to beep out any curse words. I wanted to leave those in so people have a sense of the emotional state of the people involved. So I'm going to go back. There may be a few, it's not a direct correlation between what I play for you and the violation of the SOPK elements. It may not be a direct correlation, but I ask for your indulgence on that. Okay, so here we go. So this is one very brief moment of curiosity where it shows, okay, maybe there is a learning company here.
To me, one of the attractions about being here at OceanGate, doing innovative stuff, not knowing what's going to happen, and having that intellectual stimulation and
regrouping
and tackling sophisticated problem solving.
So I think this is pretty much all lip service, and you'll see that in the remaining sound bites. But this is kind of what every organization professed to be, but very few organizations really execute this curiosity or learning new things on a regular basis. I think this was just one little this one little brief flash where things look good, but actually was not reflective of the entire company. So now I'm going to go back to the real-time monitoring system. This is where Stockton Rush. He's the one with a very confident style of speech. He starts talking about how this real-time monitoring system is going to ensure the safety of the Titan submersible.
Well, we have real-time monitoring, so we'll see. The same thing. Every time we go to 1,000 meters, it should be quieter than the last time. If it isn't, then we have serious concerns. We have a lot of mitigation plans in this that are already in place, that have been tested, and that nobody can deny. It's just nobody's done it that way before.
Okay.
If somebody comes and says, I don't believe this acoustic monitoring, I just don't believe it, I don't like electrons, I don't want to hear it, then they shouldn't die. Period. If you don't have confidence in the acoustic monitoring as a method of detecting failure in carbon fiber, you should go with something.
Okay. So he talks about the acoustic monitoring and if it's going to be the end all for assuring the safety. And I'm going to show you something later, but
resin settling in. But even the Boeing people don't know what's going on. I mean, I've asked the experts at Boeing, what is that pop? And they said you can read 5 books and they'll give you 5 different reasons. It could be the matrix popping, it could be a fiber popping, it could be multiple fiber popping, it could be imploding, it could be exploding, it could be bending, it could be, they don't know. This is cutting edge stuff.
Mm-hmm. So here, this is an interesting soundbite too, because he's telling us in the prior soundbite that he trusts the acoustic emissions, but here in this soundbite, he's telling you that he doesn't know what the indications really mean. When he hears something, he doesn't know if that's what's happening to the hull. So even though he has his system, he has no way of correlating what he hears to what's going on in the hull of the Titan. And then here's where he adds confidence to himself.
I've been to conferences on this stuff. I've talked to Boeing's top people. We had our contract with Boeing. I've spent countless hours down there talking to all of their composites people, and they're had drinks with Mark Nagley 2 weeks ago, and he was all concerned. And he said, "Hey, I'm really concerned about you. You're going to go in the sub." And I said, "Mark, tell me I'm wrong. Will I hear it on my acoustic monitoring system way before it fails?" He said, "Yes." I said, "Then I'm not concerned."
Okay. So with that in mind, I want to send you back to the OceanGate patent that we talked about earlier. One of the things I did was I reviewed the maintenance logs from the OceanGate records, and I saw instances where the real-time monitoring system provided some indications that was unexpected, and if it was interpreted correctly, could have provided clues to the state of the composite hull or to the state of the real-time monitoring system as well. Instead, all these signals were ignored and in some cases were disconnected. So this is kind of a learning opportunity. If you have a system that's not behaving that way you expected, your theory is this system is supposed to work this way. And if it doesn't work that way, you don't ignore it. From a Deming perspective or a PDSA perspective, you don't ignore it. You try to study it to understand why these signals are coming up when your theory says those signals shouldn't be coming. So that's a missed opportunity. In more practical terms for you and me, it's kind of like having a idiot lights on your dashboard and just covering up with a Band-Aid saying, don't worry, just keep going. Now, here are samples of the maintenance log that I was talking about. A maintenance log is, you go about testing out whatever it is you're working on. If something doesn't go right, you make a note of it, and then what you do is figure out what was wrong and then come up with a plan to fix it. And if you're really a good organization, if you see something that failed over here, and then you say, well, that failure mode, whatever caused that to fail, could actually affect this system over here, then you say, okay, I'll prevent that from happening again, and I'll do something over here with this other system which has a common failure mode and try to do what I can to prevent that from failing in the future. So that's kind of more like extreme blue pen company behavior. But what I'm showing here, there were at least 2 instances where the acoustic sensors were throwing unusual events which they didn't seem to jive with what it should be sending. So what was OceanGate's response to that? The solution? Disconnected. And then on August 4th, same thing. It was giving a bunch of indications when it shouldn't have been because there was no pressure in the hull. What do? They disconnected it. So that's the bolding is mine, but that's just indication that I'm hearing something that I don't think is right. Instead of trying to figure out what's wrong, I'm just going to ignore the signal. It's a great, big, beautiful world, because if I can ignore it, it's obviously not there. So this is the cover of the Titan submersible when they started advertising expeditions to the Titanic. So now I'm going to show you a little bit of kind of how flippant the OceanGate Stockton was about people dying.
I'm uncomfortable with you doing the man test as well, and I've told this to Neil, that the thought of going down to the Bahamas and bringing back a dead body would mentally fuck everyone who is down there, and that scares the shit out of me.
Okay, and if you worked for Virgin Galactic, you got 3 dead bodies. I mean, that's the nature of testing things in the extremes.
Understood. I'm just saying, it's
and
not just you.
By the way, you won't be bringing my body back. I am not dying. No one's dying under my watch. Period.
So there's a lot of arrogance and hubris presented. That's demonstrated here. Another thing that he did really well was he knew exactly everything that he needed to know, and he was not going to hear any kind of commentary or best practices from the peanut gallery. So what he's going to do in these following quotes is he's just going to badmouth established industry leaders and industry practices.
And the same thing, Spencer worked with Virgin Galactic, and that didn't end well because they're all odd dudes. Yeah, they're all odd dudes. They went to foolish death. Yeah. Did all that stuff.
How's that relationship now?
He's not going to talk to us.
No.
Yeah, because we cut his bill because we had to spend all this money to go to Unico, where he said he could machine it, and he couldn't. His machine couldn't take it by an inch. Going with him. He's getting old. We think he may be getting senile. He's got heart trouble. So, and I'm betting my life on it. And I have asked everybody I possibly can, and nobody with any knowledge in the space has told me I'm wrong.
Well, there are a lot of people that told him that he's wrong, but those are people that are not within his space. And Will Conan is one of the established experts in this field. And then PVHO stands for Pressure Vessel Human Occupied. It's a subset of ASME Standards Committee, and they write recommendations for how to design and test these types of submersibles.
Will Conan doesn't know what the facts are, period. And it's fine. You can. It's fine to poke holes and ask questions. The challenge is that I can give you the answer, and you disagree, and you stick with your approach, and you have an opinion, and you will not. I'm not going to get you off if it's not PBHO certified, even though PBHO certification means absolutely nothing. You're not going to be comfortable with it.
You're going to have to dumb this down.
Optically distort.
Okay.
So it's when it starts to stress, it starts to crack over, like a bad windshield on a motorcycle.
Mm-hmm.
It'll kind of look like scratches. Yes.
Okay.
And so that may happen. We are testing a non-standard geometry at pressures way beyond what Clarence Dashew did, in sizes way beyond he ever tested for, and he's the only person who ever really did. Mm-hmm. And everything in PBHO is based on Statue's work. And they pray to the god of Statue, and they all know, he even said himself, he didn't do all these different geometries. He tested the most of them, and he has great data, and there's lots of supporting stuff. But everybody admits that it was very limited, and that's why PBHO is not a standards committee. It is a volunteer group. It is not like a DOT standards. It is a bunch of volunteers who have their head up their ass in certain ways, and I'm going to go prove that. But that is for me to prove. That's why I'm going to do the dive.
So here's so he had testing and analysis performed on the composite hull, and neither of those things agreed with each other, but he just chose the one which was more to his favor, and he decided that was going to be his whatever was closer to his reality is what he believed. There was no attempt to reconcile the difference between the analysis and the testing.
I'm telling you that our experience with Spencer, everything Spencer has told us has been wrong, which is the depressing part. Every part that he's told us that is wrong has been in our favor.
So, right or wrong doesn't matter as long as it comes close to what his vision of reality should be. So this is an example of taking the time not to study this discrepancy. Just take whichever is favorable outcome, and that's the gospel. And now, no appreciation for the system.
The thing, Stockton, I think you have to listen to me here. The main thing which you are sweeping under the carpet here is if something goes wrong with you being in that submersible, okay, your topside support. Those are the ones that are left with the aftermath. Those are the ones that are left to answer to the accident investigation team. OceanGate is done. Everybody says, oh, it'll just be Stockton's wife. That's the only person you can be liable for. Nonsense. The accident investigation team will come down. I understand. It would shut the industry down. I understand, and that's bullshit, but that's fine. Okay. Well, we don't need any, quite frankly, everyone is replaceable. It will be a huge loss to lose him. We'll have to recover through it. Because I can't have him questioning everything, the process. You're going to be...
So he wants to be the one in charge. He doesn't want to hear any pushback from anybody in his organization. And this,
before you could do it, the issue is equality from an operational perspective. What you've done is equality from an engineering perspective. I didn't hire you to be an engineer. I hired you because you understand operations. Right. And so in order to determine the quality from an operational perspective, you need to know.
So this is a stay in your lane. It's an indication that OceanGate is not a system of different organizations working towards a common goal. It was just a bunch of silos trying to just keep their best from getting fired by Stockton, basically. So there's a little bit of, I'm sure you've seen this.
He's been trying. I get he said, she said from all of this. So the fact is, I know. I'm getting all the answers, and I'm the guy who's listening to everything that Tony's saying, everything that Will Conan's saying, everything that Boeing's saying, everything that Brian Spencer's saying, ATK, BD. I'm the guy who's collecting all that data. Okay? It sits here. And if you don't have confidence in the CEO, then that's the wrong place to be. And
so this is, I like that soundbite because the density of the word I is huge, and I'm sure you've seen that in other places too. Another example.
And where I'm getting to this thing is, this is the future of the company. This is the path I've determined to take. This is the test program I've determined to take. And I've been working on the engineering, and I'm comfortable with it. And that's why I'm the only SOB who's going into this thing. And I'm not going to force anybody to go into it, and they can all look at it later.
Yeah, he didn't force anybody to go into it, but he also told everybody that it was safe. Join my religion. That's a little bit of megalomania right there.
But I don't want to force people. We're doing weird shit here, and I am definitely out of the mold. There's no question. I'm doing things that are completely non-standard, and I'm sure the industry thinks I'm a fucking idiot. And I know Patrick Leahy's telling everybody we're stupid fools. That's fine. They've been doing that for 8 years, and I'm going to continue on the way I'm doing. But I'm not going to force people to join my religion if they don't want to.
So communication between the organizations. Here's some example of how disconnected the communication was.
The frustration is trying to get additional knowledge from Tony. He's not here to defend himself. He puts up walls. He stops you at, I want to know this stuff. And granted, he's willing to teach me about strain gauges, and that's great. But I feel like everything else is, trust me, I'm an engineer, and you don't need to see that.
So do I.
And that's frustrating. This group should be the most open group. We should be talking with each other constantly. Pilots, engineers, operations, we should all be on the same page. And it's an us against them, and that's going to kill this company.
Yeah, no, and it's been there for a number of years.
And then here's
for him to just say no, you can't see it, because, and I mean, he's not saying it in so many words, but he's saying you're too dumb to read the stuff.
Right. So.
But shouldn't he, as the head pilot, and me as a potential pilot, be at least allowed to ask questions so that we have that peace
You're
of
welcome
mind?
to ask questions.
Absolutely.
But you know, if you ask a question about an O-ring and we give you our engineering answer to the O-ring and you say, I don't believe it, I don't know what else I can do there.
So the counterexample to that is Richard Feynman, when he was reporting to the Rogers Commission investigating the Challenger disaster, he was very easily able to communicate things that can happen with O-rings to a bunch of congressmen. And if you can convince congressmen, then you should be able to convince anybody. And now when it comes to safety...
I'd be happy to answer that if you're really interested in
Yeah, well, you can, I mean, it is my life on the line in this thing. So yeah, I
I'll
feel...
explain it. Okay,
Well,
so anyway, let's keep going on this thing.
So Bonnie Carl says, it's my life on the line. And just 2 beats later, Stockton Rush says, well, let's keep moving. So that kind of gives you the amount of concern that Stockton had for the safety of other people in his organization. And then the final insult. This is now Stockton addressing David Lockridge directly.
So, one of the obviously a concern here is, to me, it's clear that there is not a lot of confidence on your part in the engineering that went into this vessel, and that your experience in other vessels gives you serious concerns about the safety of Cyclops 2 from a very fundamental level, from the carbon fiber, and then you have serious concerns with the safety of the test procedure and me going in and not being dropped on the road. And you have some very serious concerns. And I don't believe we have alleviated those concerns in this meeting at this point. And I don't believe we're going to alleviate your concerns. That's a problem. You're a great pilot. There's no question about that. And you've done a great job on Cyclops 1 and Antipodes. Clearly, Cyclops 2 is not something you are eager to jump into, because it is, from what you're saying, you have these serious safety concerns.
Oops, sorry.
That you're not going to get a comfort level.
I do, and this is the first day we've ever had proper sit-down, all of us, to discuss all this. Okay, I now know where we're at.
Here. So now, here's the timeline. This meeting took place on Wednesday, January 19th, 2018. The following Monday, on January 23rd, David Lockridge was presented with a termination letter. And the termination letter was effective January 19th. Mr. Lockridge filed a complaint with OSHA in February. And then OceanGate filed a countersuit on the 25th. No action was ever taken by OSHA. Both claims were dropped in 2018. So from this meeting to the time of the Titan submersible disaster, they had 5 years to address the safety concerns that David had brought up at this meeting. So now, going back to the MBI report. Now, the MBI report, I think, is about 800 pages, if I recall. There were 6 pages of conclusions that was presented. And the one that jumped out to me was this one here. Paragraph 6117, OceanGate's toxic safety culture, corporate structure, and operational practices were critically flawed, and at the core of these failures were glaring disparities between their written safety protocols and their actual practices. Now, the interesting thing here is, from my review of the engineering data, there weren't even written protocols. So there were things that they said they were going to do, and the things that they should have written down, and the things that they were going to do following these procedures. It was all talk. The written procedures, I couldn't find any, and there was no indication that anybody followed anything. So, but this was one of the conclusions out of 6 pages. There were at least 3 or 4 or 5 other bullet points that talked about the culture at OceanGate that contributed to this broken organization, that contributed to the failure and the death of these 5 people. So going back to my little snippets from Richard Fagerlund's book, Trustology. If you go through here, you'll see each of these things being violated through the sound bites that I presented to you. Be clear and consistent with desired outcome. Presume positive intent. Understand where individual members of your team are coming from. Be compassionate, empathetic, welcome feedback, see people as allies. Don't take offense. Ensure that the team knows why, and monitor how the team relates to each other. Don't keep a scorecard. I think looking back on the last bit of sound bites, all these have a big red X through them. So now let's take a look at this chart again using OceanGate as the reference. So what happens? Okay, what did OceanGate do right? They did consumer research very well because they understood that there was a marketplace and a need for people with lots of money to have one-of-a-kind adventure experiences. And so he got that right. Okay, let's move on. But then design and redesign, testing, production, assembly, all these things were done pretty much, pardon my French, I would just say half-assed. And so instead of happy customers, what do you have instead? You have this. So this goes beyond pity the customer. This is condolences to the family. So now I've given you a little peek behind the curtain at a true red pen company. And boom. So you bleed red. And what do you hear a lot of in when you talk to NTSB or FAA people? Regulations are written in blood. So now you've had a little bit of a peek, or at least a listen behind what goes on at a red pen company. The question that I have to you is, where do you live on this axis? Here's some references if you want to dig a little bit deeper. And that's it. Thank you very much. I'm open up for questions. Thank you, Robert.
Yosh, you said there was a 5-year period between when the submission was made for the OSHA investigation and it never really happened?
No. The meeting that I'm playing the sound bites from, that was a 5-year gap. So the U.S. Coast Guard didn't get involved until after the disaster. So David Lockridge in, I think it was 2018, raised the red flag saying, I have serious safety concerns about the Titan. You don't do this, you don't do that, you haven't done that, you should be doing this, blah, blah, blah. So that was, thank you for your input, David. Here's your walking papers, get out. So everybody in that room was aware of David's concerns. Bonnie Carl was also, who was training to be a pilot, all of a sudden is saying, well, I don't want to die. And then Stockton says, well, don't worry. If anybody dies, it's just going to be me. Don't worry about it. And then where David jumps in and says, no, it's not just you. You could screw up the entire industry depending on how bad it gets. So it's not just you living in isolation. You're part of this ecosystem of other people trying to do the same thing. So they had that for, after that, there was 5 years. They had 5 years to try and address those concerns. Instead, a termination letter, and then from that point forward, just business as usual. Stockton knows everything. Whatever Stockton wants to do, he does. But David Lockridge wasn't the only person to get punched out. There was other directors of engineering, other people involved in quality. There's a bunch of other people who had come and gone throughout during that period because they didn't feel comfortable. I think David Lockridge did file a complaint with OSHA. OSHA was overwhelmed, so they never really took any action, which is another unfortunate thing. And then because of the pressure that OceanGate lawyers put on David Lockridge, he withdrew his complaint with OSHA anyway. So at that point, they couldn't even do anything. So
okay, so the OSHA investigation that was warranted never happened.
Correct. And he was, I think the OSHA investigator was called to the MBI hearing. I don't know that for sure, but I think he was there. So, hey, Robert, please.
Question, Yoshio. What's your position on that acoustic monitoring system? And I'm asking because once you hear a crack or something like that, that normally means that there is a disintegration or a delamination or whatsoever at a point where the stress on the hull is already very large. And if you then lose some of the integrity, how useful is that acoustic monitoring system? Because I think you get a rapid escalation of the situation.
That's kind of my feeling as well. Now, yeah, so yes, but the intent was that there's always a little bit of settling or breaking in that takes place. So the first couple of dives, you're expecting to hear some noise because the first time you load it up, things are going to settle. But after everything settles, you expect everything to go quiet and stay quiet. But instead, something happened on dive 80. Something huge, completely unexpected happened on dive 80. And they said, well, it wasn't at depth, so it can't be a pressure effect, so let's ignore it. I'm putting words in their mouth. They may not have said that directly, but that seems to be the impression I get from looking at the commentary after that event. And so, I'm sorry. So, yeah, but they never did anything that said, if you start hearing this many indications, you have this many more dives before you have to retire the hull. They never try to correlate, if I hear this, it means that. There was never that correlation drawn. So, and you heard that in the sound bites. Well, they don't, I've talked to experts and they don't know what that noise means. Well, if you don't know what that noise means, then you don't know what kind of damage is going on in the hull. And you don't know if that damage is going to be catastrophic or if it's just settling. So, hope that.
Has the hull never been replaced? Because I would expect that after a few dives, you replace the hull and you take the old hull and you dissect it and you look at fibers breaking, delamination, things like that.
Yeah,
never done?
So you're talking from a blue pen company perspective. What I saw was that
obviously
he was very confident that everything was right and went well. And one of the things, so in aerospace, which is my background, sort of, one of the things that we design for is how many hours of flight is this piece of equipment going to be good for? How many ground-air ground cycles is this landing gear going to be able to withstand before we have to replace it? So during the design and analysis and testing, there was no attempt to define how many times we wanted to go up and down.
Mm-hmm.
So basically it was just going to be a one-time analysis. It was never going to be a cyclic loading type of study that was done. No testing was done to look at cyclic loading. No analysis done. No intention to define the number of cycles. So if you don't have requirements, you don't have to do anything. So there's nothing to address. Does that answer your question, Robert?
Yeah. And then there's one other thing. At the beginning, you were talking about the theory that people actually verify. Personally, to me, theory is a little bit, even though theory can still be challenged, but theory is something that is relatively established. Whereas I would like to talk about hypotheses instead of theories that are being verified. But that's the only thing that.
Yeah, I guess there's different levels. There's the theory or hypothesis, theory, law, and then becomes axiomatic or not dogmatic, but at the highest level of verification. But even laws are subject to modification, right? I mean, Newton's laws of motion are only valid up to a certain point. Relativistic laws of motion say something completely not completely different, but now the
refined.
Newton has a little, now there's a correction factor that's thrown on top of it, and then you get into relativistic things, and then quantum. Then all of a sudden, you're not even talking about something moving in this universe. You're talking about that thing moving in this universe causing something else to move in another universe. So, anyways, neither here nor there, but yeah, but that's kind of the structure that I've been using theory as a starting point. But you're right. Hypothesis is a little bit lower in terms of confidence. Thank you.
Yeah.
Yoshi, you mentioned at one point we were talking that Stockton believed that composites were good in compression.
Yes.
Want to talk about that?
Yeah, he made a claim, I think in one of the sound bites, or I may have cut it out, but he made a claim that composites were better in compression than they are in tension. And I'm going to go prove that to everybody. And it's true to a point if you acknowledge that composites are called orthotropic materials, that the properties in one direction, properties in this direction are different than the properties in this direction. In this direction, if you pull on it, it's very strong because the fibers are very strong. If you do this, if you compress on it, it's very weak because the fibers individually are just little strands and they'll just buckle. And when they buckle, they delaminate from the matrix material, and so all of a sudden you have no strength. Now, what Stockton was talking about in compression was if you take a composite layup like this and you squeeze this way, yeah, it's going to behave pretty damn good. If you have a block, it's going to behave well. If you do this along the line, along the plane, no, that's not a good day. So Stockton was kind of mixing things. I'm thinking that's what Stockton was doing, so he can say that composites are good in compression. There's another company called Triton who actually have been successful in designing composite hulls for compressive loading. But they also have, I think they have a little metallic structure beneath it as well to help. But I don't know all the details yet, but composites is not an absolute no-no. It's just you can do it for buoyancy advantages, but you have to do it right, and you don't just do composites exclusively for that type of application.
I think also there was something also like sort of unique about the submarine was that it had a cylindrical pressure vessel, and it also had, I think, if I'm correct, steel end caps.
Titanium,
Titanium end caps. So could you maybe speak to sort of the challenges that would have presented?
Yeah. One of the beauties of composites is that they're not very sensitive to temperature changes as far as geometry goes. They don't, but on the other hand, titanium is. They have a pretty high coefficient of thermal expansion, or at least not, maybe an order or two magnitude greater than what it is for composites. So as you go down in depth, the temperature drops and things start shifting differently. Whether that had anything to do with the actual failure, that hasn't been established, but obviously that can happen. They did have problems with O-rings. They also had, but they presumed that since everything in compression, everything's going to be mushing against each other, therefore, any kind of gaps that can form, well, they're going to get closed upon compression. So at the great big beautiful world, boldly go forth. But there's other, at that depth, I think the pressure is about 4,500 psi. Atmospheric is about 14.5 psi. As a point of reference, the pressure that's required to drive aerodynamic control surfaces on a commercial airplane, the hydraulic actuators that push and pull the flaps and stuff, rudders, they hum along at about 3,000 psi. So it takes 3,000 psi to drive the control surfaces that move airplanes around. The depth at it's the pressure at that depth about 4,500 psi. A little pinhole hole in a hull in the Titan would have created a water jet so intense that would just burn. It would just right through you. It'll just cut you in half. So that's just kind of a reference point for what kind of pressures we're dealing with.
Yeah, and it's also much different from something you'd see in like aviation or space, where, you're looking at atmosphere, sea level 14.7 up to like zero, and
Yeah,
that's just a
yeah,
14.7 psi difference, as opposed
exactly.
to atmospheric to, the depth of the Titanic, which is you're saying was
Yeah. You remind
4,500.
me of a episode of Futurama where the Planet Express spaceship gets sucked into the deep ocean, and somebody asks the Captain Leela the question, "How much pressure can this thing take?" And well, it's basically a spaceship, so only one atmosphere. So, anyways, yeah. Sorry, that was a stupid aside, but Diane, I know you have some thoughts.
Well, we kind of explored how do we facilitate a more constructive behavior, and that's what all of the red pen, blue pen concept is about, right?
Mm-hmm.
So here you got a guy that's being arrogant, dismissive, goes along with that. Lots of assumptions, dismissing anybody who challenges those assumptions. And, as we've discussed before, you and I, that's pretty rampant in engineering firms, especially those that have a few achievements under their belt, based on my observations anyway.
Yeah.
And trying to change that behavior requires an openness to changing that behavior on the part of the people that are the perpetrators of that.
Mm-hmm.
If you don't have that, in my case, I usually have to make a decision. Am I going to continue to, beat my head against a wall? Or am I going to go somewhere more conducive, right?
Yeah.
I hate that decision, but I often arrive at it because when I'm delivering news about things that people of that ilk don't want to hear or confront or address, they don't give you a lot of options for staying within the organization. A lot of retaliation.
Yeah.
So how do we get leverage without going outside of the organization? Because I think that's a layer of complication and confrontation that makes it even harder. How do we get leverage to change an organization that's being governed by this type of behavior?
Yeah, I thought about that a little bit too. Do you have something, Bill?
Well, what I was going to say is, I think that the leverage in that situation should have been OSHA.
Right.
But that is external, Bill.
No, but at least that becomes, if you're looking for something big to weigh in,
it's kind of like saying FDA should make medical device manufacturers toe the line on patient safety.
But the challenge is, it's having leverage like that internally is challenging.
Yeah.
You're going to get squashed like a bug.
Yeah, pretty much. And I'm looking at human behavior in general as I'm trying to build this synergy with AI. I can't even really put myself in the shoes of a machine learning algorithm that goes out to the internet and looks at what's available and tries to assess how to deal with human behavior. We are so so across the board in our behaviors, and so many of them are not rational. Even dealing with one irrational human being in an organization, in my opinion, can crash the organization.
Yeah. Well, rationality and that's kind of more of a perspective thing. I read an essay by Russ Acuff many years ago, and I don't have it's not a solution to what you're talking about, Diane, but it kind of points to the cause. And it has to do with the behavior of publicly owned companies versus privately owned companies. Publicly owned companies that have to report to Wall Street on a month-to-month basis. That's the financial pressures that are put on the people at the top. So there's people at the top, the CEOs and CFOs and all that report numbers to Wall Street on a monthly basis. Mm-hmm. And then the people below at the lower level who are customer facing, they're trying to do the best they can for their customers. And then there's people in the middle who are caught saying, I got to look after these people. But at the same time, I'm getting pressure from the upper management to say, report your numbers, ship X number of dollars of product, deliver X number of dollars worth of services this month. You know? Yeah. So that pressure or the pull from Wall Street drives some of that red pen behavior, because there's a disconnect between who these people serve, Wall Street analysts, and who these people serve, the paying customers. Those two things are hard to decouple in a public organization, publicly traded company. In a privately held company, you don't have that pressure. And if the actual shareholders of that company are patient, they're willing to go off and do the right thing for the customer. It may not be, they may not have great IPOs or anything like that, but they have a healthy, sustainable, hopefully, business. I heard this great story a couple of years ago about a company, I think one of the medical companies, I'm not sure which one. One of the scientists developed an anti-malarial drug. Hooray for us. He said, look, this is really cheap. Give me X million dollars to develop it, and this could wipe out malaria in Africa, or whatever the claim was. The company said, the leadership said, well, what's the benefit? Well, it's going to cure. Well, how much money is it going to make us? I don't know. These people in Africa that have malaria, they don't have money. But the guy said, okay, just give me this much. And so under the, basically very covertly, leadership gave this scientist X number of dollars to go fully develop it. They took it out to Africa. They eradicated malaria or something in a very small region. And then this is great. We could expand this. And they started thinking about it. And then the news got public and went to Wall Street. Guess what happened?
The companies that made money by treating those with malaria killed it.
No. The stock market says, we don't want you doing business ventures that in an area that has no money. Therefore, we're going to devalue your stock. So the stock price for that company tanked as a result of that announcement. So, you want to know about red pen, blue pen behavior and what drives it?
Greed.
That is that. I mean,
yeah. This kind of goes back to that greed, speed, and need thing that I shared last time we spoke. Mm-hmm. Where it used to be that when you talked about quality, you had to balance that against on-time delivery and profit. Mm-hmm. Right? So I flipped that around and said, okay, profit is greed, on-time delivery is speed, and then you've got quality, which is what the customer needs or what the patient needs. Mm-hmm. And it used to be that the traditional organizations would try to balance those three things, at least publicly. Mm-hmm. Privately, I believe greed drove everything.
Well, that's where the pressure comes from, right?
And speed was kind of a stepchild to that, because the faster you could ship things or make things or sell things,
time value of money,
you grew the bottom line. Yeah. But quality was always off, bastard stepchild, right? Nobody really wanted it. It was always expense. It was always waste. If we built it right, we don't have to inspect it. The whole Six Sigma cry of battle was about that.
Yeah. But I'll give you another perspective on that, Diane. You know how corporations love to measure, because what's his name told us that you can't improve what you don't measure, or you can't manage. So what's easy to measure? You can measure money, right? You can measure revenue. It's right there. Somebody sends you a check, that's revenue.
Yeah.
You can measure on-time delivery. You put a stamp on it, get it out the door. Okay, it's measured. You can't measure quality as easily, so you don't pay much attention. It's hard to pay attention to quality.
Well, I could tell you that there's zillions of ways to measure it, none of which are actually
but it's not easy and it's not immediate.
Yeah.
Like, for instance, we talked about reliability and MTBFs. MTBFs aren't measured until the thing's been out in the field for 10, 15 years.
Right.
So,
and of course, they used to say conformance to specification, but we all know that there are a lot of things that are required for quality that aren't documented as specifications.
Yeah.
Don't kill the patient would be one.
hey, Robert, please.
How would you compare this ocean thingy with, for instance, the NASA
Challenger
moon landing, and especially with the Apollo? I think it was Apollo 1 or something like that, where they had pure 100% oxygen in the cabin at normal pressure, which led to an enormous disaster. And of course, they redesigned their procedures, but that happened more or less same way as this happened. I mean, just pushing, ignoring normal logical thinking.
Right, and funny that you bring that up, but that was one of the contributing factors to that fire on the ground was Velcro. And I mentioned Velcro.
Oh, really? I thought it was an ignition from a switch.
Well, it was an ignition from a switch, but it was sustained because Velcro was such a lovely fuel in a high pressure, oxygen-rich environment. So, but yeah, I think NASA's gotten smarter since then, with few brief moments of out-and-out stupidity, Challenger disaster being one of them. But again, that was one of those existential threats that if they didn't get this thing off the ground, Congress was going to start shutting down funding for NASA. So if you can take a lot of these things, that stupid things that blue pen companies do, could be driven by financial considerations. Boeing 737 MAX, as an example.
The MCAS system. Oh, yes.
Yeah, the MCAS system. But a lot of that had to do with the cost of certifying a brand new aircraft.
And with the cost of just a few more sensors. Instead of having 2 or 3 sensors, they had 1 sensor.
Correct.
I mean,
yeah.
If you're what is it? The pilot tube freezes, then that was the situation with I think the plane that flew from Brazil to Paris.
Yes.
20 years ago. They thought that they had 0 airspeed, even though nothing happened. Nothing wrong was there. I mean,
but that's one of those things where if you say, well, we need 3 sensors because it's a critical system. Oh, shoot. That means we got to go through a whole another level of rigor with the FAA. So let's just play it as something that's just small change. So we only need 1 sensor. So FAA, don't you worry about it. Yeah, exactly, Robert. So that's so putting multiple sensors sends up a red flag saying this is a critical safety system. We need a voting of sensors in order to determine what to do next. So if you have 2, you don't know. If you have 3, then you can at least have a voting system saying, okay, there's an indication something's not quite right. So, but
you're talking about redundancy?
Yeah, redundancy. Well, I call it a voting system.
Okay.
But if you have 2, you don't know which one's right. If you have 3, you have a chance of knowing what the right answer is, right condition is. So, anyways,
I noticed something this time around that I didn't notice previously, and it's a concern that I'd like to see us address better. But it kind of goes to lessons learned, and how do we capture that, and how do we capitalize on it? If we're able to be a learning organization.
Of course.
But storing that thing out in the snow and ice in Canada with a panel missing and only the front viewing port protected in any way, and I'm not even sure that's an adequate way.
Mm-hmm.
You know, I've so often heard of, for instance, even raw materials, metallic materials being left on a loading dock, you know, for months on end in the rain. And then they've got, you know,
Yeah.
from corrosion. I just, why do we not learn from these things? What do you think? And how can we leverage that? You know, lessons learned to prevent it from happening so often. I was shocked to see that.
Well,
I must have looked away for a minute last time you were presenting and didn't.
Yeah. No, that one was as far as OceanGate goes, by that point they were facing pretty significant financial pressures. So to actually rent environmentally controlled storage space was not affordable at that time. They were feeling pressures of having to refund passengers or mission specialists their money back, and they needed every dime to keep moving. So when they had a choice of storing it out in the open or paying to have it stored in a much better condition, no. In fact, there was, I think there's things in the MBI report that talked about they started out with a much more well-equipped surface support vessel, but as time went on and the money got tight, they went to a different, cheaper surface support vessel that didn't have necessarily all the bells and whistles that was needed to ensure safe dives.
So I think this goes back to what Bill said about OSHA would have been the leverage needed to do a better job on things of this nature.
Yeah.
Because, you know, I remember going to an FDA meeting once and they were talking about, you know, how a startup company could succeed with a submission. Mm-hmm. And the amount of things that were required prerequisite to that submission implied that you had the budget of, you know, some megacorp.
Sure.
You know, a small startup can't do it.
Yeah.
And I had a startup at the time, a vitamin company I founded. And I was naively sitting in there listening to what they were talking about being required. And I said, well, a startup can't afford some of the overhead required for the systems you're describing. And the director of the FDI office and I, who later became pretty good pals, looked at me and he said, you've obviously mistaken me for somebody who cares. We're here to protect public safety. We don't care whether or not you have the budget to do what's required.
Right.
Yeah. So that was a, you know, sit you down and make you see the light kind of moment.
Yeah.
And it explains why so many great ideas never make it to market.
Yeah. But this case with OceanGate wasn't a matter of cost because they obviously had enough money to sick a bunch of lawyers on David Lockridge. It was a matter of that OSHA didn't have the bandwidth to look up into this little itty-bitty company. So that interaction you had with the FDA, that equivalent interaction never occurred between OceanGate and OSHA.
Well, and I voluntarily subjected myself to it as this CEO of my little company too.
As you should.
Yeah.
That's the right thing to do.
Yeah.